Hello students, today I am going to explain the properties of definite integral. These properties will help us to find out the problems of definite integral in easier way. One of the method that we have studied in previous video was just using the indefinite integral in solving the problems of definite integral. But in this video, the properties that we are going to explain, that we are going to learn, are very helpful in finding out the integration of definite integration of the problems which either are very difficult by using the method of indefinite integral or which are not possible to solve by using the methods that we have already studied. Basically, there are 7 properties of definite integral. In this video, I'll explain only 4 of them and related problems I'll take. So, let me explain these properties one by one. Here is the first property. According to this property, if we are having definite integration of a given function fx limits from a to b, then it can also be written as with the same limits, that is from a to b, just by changing the variable. Means if we are changing variable of a function, then there is no change in the value of definite integration. How this is? Because you know that when we are performing definite integration, then variable whatsoever it is replaced by upper limit and lower limit, and we can prove this very easily. So let me prove it as we have done earlier. That let small fx having its integration as capital Fx and integration of fz, small fz, let us consider capital Fz. So now using limits, we know very well that a to b fx dx is having its derivative as fx using the limits. So we can write this as fb minus fa. Now taking RHS of it, so it is a to b fz dz. Its integration can be written as fz as I have considered over here, and limits are from a to b. So again, if we use the limits, we are again getting fb minus fa. So both are same. So it means if we need somewhere to change the variable, then we can easily do it, and there is no change in the value of definite integration. There is the second property. It is very obvious that if the limit is from a to b of a given function, and if we interchange the limit, then a minus sign will appear in front of the result. How this is? You can prove it very easily as we have done. Let integration of fx is small fx is capital Fx. Then using LHS side, we are having a to b fx dx can be written as fx using the limits a to b. So the result you know very well is fb minus fa. Now taking RHS side, RHS is minus b2a fx dx. So we know, as we have considered, integration of fx is capital Fx. So it is fx with negative sign outside, which is already we are having, and using the limits b to a. Now negative of this using upper limit fb minus fa minus fb. So if we take this minus sign inside, again we are getting fb minus fa. So therefore both the results are same. So the property says if we interchange the limits, then a negative sign will be there in front of the whole integrand. There is a third property in front of you. This is the addition of the two functions and limit is from a to b. Then it can be easily written as the limit remains same a to b, and we can separate the functions fx and gx into separate integrands. So similar wise, if we are having negative sign over here, we can do the same, or we are having more than two functions, then we can segregate them by the same limits with each and every integrand. Okay, so you can prove this property very easily as I have done in the previous properties. Now, a very important property is there in front of you. About 80% of the questions will be solved by using this property. So, let me prove this property. It is 0 to a fx dx. And the RHS is we are changing x into a minus x. A we have taken from upper limit. Whatsoever is the upper limit over here, we'll change this x into upper limit minus x. So the value of this integrand will remain same if we change x into a minus x. So let me prove this property. To prove this property, let us substitute a minus x as t. So we are having minus dx is equal to dt. Let us have changes over here. This is RHS. So we are getting integration of 0 to a. As I told you earlier that we need to change the limits as well if we are going to substitute method. So if we change the limits, then when x is equal to 0, then clearly t will be a. If we put x is equal to 0 here, then t is a. And if we are putting x is equal to a, the upper limit, then it is clear that we are getting t as 0. So we are getting minus dx as dt, means dx is equal to minus dt. Then limits are now from a to 0. In place of 0, we are having a. In place of a, we are having 0. So the new limit is a to 0. And a minus x we have substituted as t. So therefore, we are having ft dt. So the new function after substitution is minus a to 0 ft dt. Now, as just I told you in second property, that if we are interchanging the limits, means lower limit to upper limit and upper limit to lower limit, then a negative sign will appear over here in front of the whole integrand. So what will happen? If we interchange the limit, then it will be 0 to a ft dt. This negative sign will disappear. Now, using property number 1. Property number 1 says that we can interchange, we can change the variable in any of the form, either in x or in y or in z, whatsoever we need. So here in on LHS side, we are having the variable as x. So let us change this t into x. So further we can write this as 0 to a fx dx. So which is nothing but simply is equal to LHS. So this property, as I told you, is very useful, and we will use this property in many of the questions of this chapter. So now let me take some problems, some examples to illustrate these properties. So here is first illustration in front of you. If you remember, you can simplify this question very easily by using indefinite integration formula also. Divide and multiply by 2. So you will get 2 sin x over here. Then adding cos x and subtracting cos x. So you will get sin x plus cos x plus sin x minus cos x. So one part will be cancelled out, only one will be left, and another part can be done easily by substitution method. So there are 3-4 steps we need to do to simplify this question using indefinite integration. But by using properties of indefinite integration, just I explained, we can do this question just within 2 or 3 steps. So how? Let me explain this. Let me consider that this integration is equal to I. Okay. Now using the property 0 to a, you should be very careful in using this property. Property number 4 that I told you is very important, is the limit is from 0 to a, means the lower limit must always be 0. Only then we can use this property. Okay, so 0 to a if we are having, and here also in this question we are having 0 to pi by 2. So lower limit is 0 and the upper limit is b, a means pi by 2. So using the property 0 to a, fx dx is equal to 0 to a, f a minus x dx over here. So let me use this property. So according to this property, we need to change x into pi by 2 minus x everywhere in each term of integrand. So let me apply this thing. I is equal to 0 to pi by 2 sine pi by 2 minus x upon sine pi by 2 minus x plus cos pi by 2 minus x. So what does it mean? It means we need to change x into a minus x in every term of integrand that I have done over here. Now we know very well that sine pi by 2 minus x is cos x and cos pi by 2 minus x is sin x. So let us change it. It is 0 to pi by 2 sine pi by 2 minus x is cos x upon, in the denominator it is cos x plus sin x dx. This is I. Now adding result 1 and result 2. This is, let me name it as result number 1 and let me name this result as result number 2. So we'll apply adding 1 and 2. So what will happen? To the left hand side we are having 2i, I plus I, and what will happen to RHS? It is 0 to pi by 2 sin x upon cos x plus sin x dx, and plus the second part of this term is 0 to pi by 2 cos x upon cos x plus sin x. Okay, so this I have taken from first result. This one is the first result and this I have taken from second. Now as I told you, property number 4. Property number 4 is, if the limits are same, we can write fx plus gx as using the same limits and segregating them. So using the reverse of that, we can write this as 0 to pi by 2 sin x upon cos x plus sin x plus cos x upon cos x plus sin x and dx. So I am using over here like a to b fx dx plus a to b gx dx as a to b fx plus gx dx. So what are we observing over here? Denominators are same. So after taking LCM, we are left with sin x plus cos x upon cos x plus sin x dx. And now what is left over here? We are left just with 1 only. 0 to pi by 2, 1 into dx. And now it's very simple to integrate. 2i is equal to x and limits is from 0 to pi by 2, and applying upper limit minus lower limit we are getting pi by 2. So the value of I is pi by 4, and this is the final result that we are having with us. So I hope you understood. You are thinking that the question is lengthy in this method also, by this method also, But here I have explained each and every step for you to make you understand. But you can skip some steps when you are doing these questions, and in next problems I am going to skip some of the steps, and in that way this question will be completed only 2 or 3 steps. Look at this problem. Now let us try it by using the properties of definite integration. As the limit is of the type 0 to a, so let us use the same property. Which one? Let me write it for you again. 0 to a fx dx is equal to 0 to a f a minus x dx. Okay, so let us use this property over here. So this is equal to I, let us suppose. So I is equal to 0 to 1, no change in the limits. Now x will change into 1 minus x everywhere. So this x can be written as 1 minus x. Inside the bracket we are having 1 minus 1 plus x. It is power n dx. Now we are having further limit remains same, that is 0 to 1, 1 minus x, and here we are left only with x power n dx. Now we can easily multiply this inside, so it will be 0 to 1 x power n minus x power n plus 1 dx. Okay, so now you can find out its integration very easily. Integration of x power n is x power n plus 1 upon n plus 1 minus x power n plus 2 upon n plus 2. And now apply the limits 0 to 1. So in the same way, we will have, when we apply 1 over here, 1, any power is again 1. So we are left with 1 upon n plus 1 here, and similarly here 1 upon n plus 2. This is lower limit minus upper limit minus using lower limit. It is 0 upon something is 0, and again this is 0. So this is the result which we are having with us. You can take LCM also over here. So if you take LCM, you are having n plus 1 into n plus 2. So the result is n plus 2 minus n minus 1. So the final answer that you are left is 1 upon n plus 1 into n plus 2. So this is the way you can simplify this by using the property. Do you remember, if we are not having the limits, then how can you solve this question? Yes, by putting 1 minus x as t. By putting 1 minus x as t, you can solve this problem without using this property. So if you feel that by using property you can do this, it's good. But maximum number of times in exam, when the question is asked from this chapter, usually it is written that using the properties of definite integration. So in that case, you are not having any option for solving the question by using indefinite integration. In that, you need to use properties only. Here is one more problem that can be easily done by using properties of definite integration, and again I am going to use the same property that I have used in the previous questions, that is the same 0 to a, as the limit is from of the type 0 to a. So we'll use the same property by changing x into a minus x, and here it is pi by 4 minus x. So for that, first of all, let me consider this integrand as I. And now using the property, you need to write down property over here. So write down, after writing property, you will write 0 to pi by 4 log 1 plus 10 pi by 4 minus x dx. Now here we can use trigonometric identity. Which one is this? This is tan a minus b. So let me use this property over here. Log 1 plus This is, you know very well, 10 pi by 4 minus 10x upon 1 plus 10 pi by 4 into 10x dx. You know very well that 10 pi by 4 is 1. So we are left with 0 to pi by 4 log 1 plus 1 minus 10x upon 1 plus 10x dx. Now taking LCM. So after taking LCM, you are left with log 1 plus 10x plus 1 minus 10x. 10x get cancelled. So in numerator we are left only with 2, and in denominator we are having 1 plus 10x dx. Now what can we do? Yes, we can apply the formula of log, that is log m upon n can be written as log m minus log n. There is no change in the limits, and let us use the property of log m, that is log 2 minus log n means 1 log 1 plus 10x and dx of it. Now we need to apply the same as we are doing in earlier questions also, that after this step let us add the 2 steps. Which one? This is step number 1 from where we start, and this is step number 2 that we are getting after applying the property. So adding 1 and 2. So to left hand side we are having 2i after addition, and to the right hand side one thing that we are getting is 0 to pi by 4 log 1 plus 10x dx, and with the same limits we are having log 2 minus log 1 plus 10x. So again using the property of log fx plus gx plus hx can be written as separate, or the separation can be written as the common addition. So let we write all these in one integrand. So the limit will be common, 0 to pi by 4. The first part that we are having is log 1 plus 10x. This is the first part from first relation, and from the second relation we are having plus log 2 minus log 1 plus 10x dx. So what are you observing over here? Yes, these two get cancelled and we are left with 2y is equal to limits from the same 0 to pi by 4 and log 2 dx. What is log 2? Log 2 is the constant term. So log 2 is outside. We are left only with 1 into dx, and you know very well the integration of 1 is x, and using the limit 0 to pi by 4. Now it is log 2 using limits upper limit minus lower limit, that is pi by 4 minus 0. So 2i we are getting as pi by 4 into log 2. So what is your final answer? Your final answer, that is I, is pi by 8 log 2. So in this way you can solve these problems by using properties of definite integration.